Hello friends, today in this video I'll discuss about Qwen3-TTS model and the features which are available in Qwen3-TTS model. So I checked the GitHub repo. Here I can see it has very complex detail about the different features, but I have gone through the complete uh, detail, and I have seen like there are only two specific feature which like any other TTS model which provides. One is to generate speech from text, that is one thing, and another is to clone the uh, voice, like to clone audio from a input reference audio. So these are the two things which is being provided, and there is one more new thing they have added is to add a speaker. Like they have given 9 different type of speaker available by default. So if you choose the speaker, like if you give the speaker name as a parameter while uh, calling the TTS dot generate voice design, if you send the speaker name, so it will be able to generate the voice with that speaker. So it is kind of like they have trained specific voice, and they have given the name, like using that you can kind of generate some realistic audio. So if you see here, they have given one example speaker and language, text, instruction, so all these things are there. So speaker is something like it will add some extra uh, spice into the audio, like it will be of a specific type, and the instruction is something like how the audio would be. Let's say if you want the audio to be in a very happy tone or sad tone, so you can provide the instruction here. So I'll quickly uh, show you the installation steps. So if I come here, it says to create a conda environment and then pip install Qwen3-TTS or git clone this repo. So what I have done is, like to install the conda environment, you have to git clone sorry, you have to wget this conda library. So I have downloaded my conda library. Then you have to install the sh file using bash space the sh file name, then path. So this is the path where I have installed. This is the mini conda folder where my conda is installed, and then you have to create the conda environment. So to keep the the conda files into separate directory, so I am using runpod. So in case of runpod or fastAI, if you want to persist the conda environment settings and everything, you have to create a folder inside workspace, because with runpod or fastAI or any cloud provider, they will delete the C directory, like where the container directory where your installation, like system level files are there. Every time that will be deleted, so you should install the conda inside your workspace folder, which is your permanent storage. So I have created a folder here, envs, and while creating the conda environment, just give a prefix like this prefix, then the total folder path like this, and your python version. So if I see here, coin 3 is using python 3.12, that is a good thing. And then after that you have to conda activate, and after activating the conda, I what I did is, like, I git cloned it. So I git clone inside this folder, and if I go inside this folder, you will see requirement.txt, or uh, the if I just open it here, so I can see pyproject.toml file is here. So this file is required to install the uh, all the libraries for your module. So I came inside this Qwen3-TTS folder. Now what you have to do to install it, cd into your Qwen3-TTS folder and do pip install -e dot. So that will search for the requirements.txt file and install all your library or modules inside it. So after installing the module, so if I see the toml file here, it install the transformers accelerate file and torch audio it has installed sound file. But if I go into this GitHub repo, here I can see they are saying to install the flash attention 2. So that is required to speed up the inference. So to install the flash attention, you have to make sure like you are using the installing the correct version of your uh, torch and torch audio, torch vision. So all these three things should be either below 2.8.0, because if you install torch 2.8 or 2.10, so in that case like you have to build the flash attention, and in that case like you will get lots of error, and it would take lots of time. That is the important thing. So what I have done is like I just saw like the flash attention to, if you want to install, so you have to uh, install torch 2.7.1, that is supported. So then you will get the flash attention wheel available. So I'll just quickly show you the command. So you can install the torch 2.7.1 along with torch 0.22.1, and torch audio would be same like torch, and index URL it should be CUDA 12.8. So this is the requirement, like if you want to install flash attention without much issues, go for torch 2.7.1. Then install the flash attention with no build isolation. So this is required because without it it will upgrade all the other dependent libraries. So that is required to make sure like your other libraries are not affected. So then you do a pip install flash attention. After installing the flash attention, I think there is nothing else, and you can download the models into your uh, folder, or you can simply run the inference script to download everything. So that automatically will download everything. And to download the model, so as per this code, the example code which are provided, I'll just show you where the codes are. So you have to install the Hugging Face Hub, this specific version, because without it the new Hugging Face Hub HF command will not work. If you want to try uh, the script which are already given. So inside the example folder, if you come here, you will see they have given multiple script to to with examples like how to inference, but they have made it complicated, like they have given multiple examples which could be little complex to understand. So there are only basically there are two things. One is to clone voice, like you will give one input audio and text, and based on the input audio you want to clone and generate it audio out of the text prompt. So for that you have to simply use this code. So this is very simple code I have generated out created out of this example codes. So this is kind of very simple, like first import the libraries torch Qwen3-TTS from Qwen3-TTS, import the Qwen3-TTS model and sound file. Then models, you take a variable, model variable, and here if you are not downloading the model, it will automatically download the models when you run the code. And you can also do one thing, like if you are downloading into any specific folder. So for my case, let's say I have downloaded into HF cache folder. So in that case, like you have to before running the script, you have to uh, update the HF home folder path. So for that you have to run a command like this: export HF home equals to the folder path. Let's say if I want to make it the home folder for Hugging Face model download, I will do this HF. There will be a underscore here. So HF home equals to this. You have to export this export. So before running any code on your terminal, you have to do this. Then only it will change the download path of the Hugging Face models into this folder. Otherwise, it will download everything. Hugging Face command will download everything into your root folder. So that is one thing you have to keep in mind. Now for clone test, this is the flash attention. If you want to speed up the inference, so you can use flash attention, or SDPA also can be used. But make sure like flash attention, it requires uh, the torch, the DT type, like the model type should be BF 16 or float 16. So that you have to keep in mind. And here is the reference audio. Reference audio, you can either give uh, so you can either give reference audio, the web URL, or you can give a local path directory path also. Like if you are keeping the mp3 file into your folder, you can give the folder path here. And this is the reference text. So reference text is kind of like what is being said on this audio, so that you can give, like, to make sure the model is 100% accurately generating the clone. But this is not required. So if you don't want to provide the reference text, make sure, like, you when inferencing, you change it to this x vector only mode to true. So if it is false, then it will look for this reference text, and if you change it to true, in that case it will ignore the reference text. And then here you can inference the model, like model dot generate voice clone, then your text input here, language here, and reference audio, reference text, x vector only. I made it true because I don't need the reference text. And instruction, I have seen, like, with cloning, instruction does not work. It only works when you are generating the audio from text. For cloning, there is no role of this instruct parameter. And here in the end, it writes the file into your folder. So that is for cloning. And if you want to generate the audio from text, so in that case there is this another method, TTS dot generate custom voice. So here they have given option to uh, select the speaker. So this is very basically same thing. The model is different here. So for custom voice and voice design, so there are two model like for text to audio generation. With custom voice, they have given the speaker option, like you can select the speaker. So and with voice design, they have not given any option to select the speaker. You can simply generate the audio from text and using the instruction. So I'll discuss about this model, the custom voice model. So this model, it has, it takes first the text prompt, language and speaker and the instruction. So instruction is something like how you want to, the audio to be. So that is the thing with instruction. Like if you might have seen with Chatterbox TTX, it you can add the tag like emotion tag. So same like this, you can add instruction here. And if you want to see the number of speaker, so they have given total 9 type of speaker. So these are the speaker value, like these are the value of the parameter you can pass. This total, I think there are 9, yeah, 9 speaker variable they have provided. So you can use any of this and generate the audio. And for batch generation also it is same thing, like you will just pass the instruction and everything like array. So here let's say for the text I have passed it as a string. So in case of batch generation you have to pass it like an array. So batch generation, I don't see any usage of batch generation, but in case anyone want to generate in batches, like they want to have a two-way conversation, in that case they can go for batch generation. So they have also given the example for batch generation like this. Let's say you can pass the text in an array, languages in an array, and speaker instructions. So everything you can pass in an array, and then uh, you know generate the audio. So I have generated multiple audio files here, and I see like these are quite good. This is not that bad, to be honest, and they are also planning to uh, release the better model. Like I think they have a plan to release. This is a 6 and 1.7 billion model. I saw somewhere they are planning to release a better model soon. So I hope like with time this will be better. Like you will be able to get a, almost like 11 labs types of audio output from this Qwen3-TTS model. And this is totally open source if you want to train for any other languages. So for that they have given the fine tuning code here. So you can use this fine tune code and prepare your data and do the training for other languages. I guess they have given support for 9 or 10 languages at this moment. If you go to the Qwen.ai/blog, so there you can see all the details, like all the capabilities of this model. So they are saying it is open source. You can fine tune it, you can train it, and you can train it for different languages. So that's it for this video, because I don't see anything else that much uh, to discuss about TTS model, because there are already lots of TTS model available, and I have tested multiple TTS models, and I see like it's kind of like every TTS model is almost more or less they perform the same kind of, like they all are kind of almost at the mature side, like it's if you use Chatterbox or Index TTS or Qwen3-TTS, it's everything almost all are like generating same type of uh, audio. So I don't see any much of improvement on that space, like audio generation like TTS space. The new thing could be like in TTS generation, like audio generation space. It could be like real time audio generation, like a duplex audio generation. How there is one new model is released recently. Mm, something is Personaplex from NVIDIA. So that could be something interesting in audio generation. Otherwise, I don't see any new thing. Uh, so that's it for this video. Thank you. Bye bye.